Okay, let me do a real quick lecture on friction, so that way you can be prepared for the test. This lecture actually goes in, the notes are part of your Move the Shoe friction lab. So we'll start out by introducing friction. Friction is the force that opposes motion. So anytime an object is moving, it's going to have some sort of friction force that's opposing it. Friction is caused at the macro level by the close contact between two surfaces, as it says right here. So this is at the macro level. So this is when two surfaces come in close contact with each other. Straightforward. And then at the subatomic level, or the submicroscopic level, so this is where you can't see it, friction is caused by the electromagnetic attraction between the molecules and other subatomic influences, such as the nuclear influence of the nucleus of atoms. And yes, so that's what causes it. Moving on now. There are two types of friction, broad category wise. There is static friction, and static friction is the friction that you must overcome in order to get an object that is at rest to start moving. So if an object is sitting there at rest by itself, the key here is at rest, you must apply an amount of force that is greater than the static friction, so that's greater than the static friction, in order to get the object started moving. And this is the highest level of friction of the types of friction that we're going to go over. So this one has the greatest amount of friction. It takes the most force to overcome static friction. The next amount of force to overcome static friction, the next in line is kinetic friction. So kinetic friction is when an object is already moving. And this is the amount of force that you have to apply to an object to keep it moving. So when an object is already moving, you have to apply enough force, a force that is equal to the kinetic friction will cause the object to continue to move at constant velocity. So this is the force that you have to continue to keep overcoming as your cars are going down the road. If you want to be on cruise control, the engine has to apply enough force to overcome the kinetic friction. And so in terms of greatest to least, static friction's first, kinetic friction's next. And then kinetic friction can be described in three ways. So we're going to break down the three different types of kinetic friction that's found out there. The first type is sliding friction. So this again is from greatest to least. So sliding friction is the greatest of the kinetic friction types that are available. And here's some examples, sliding, dragging, all those things. So you got a guy sliding here, he's sliding down a rail, you can drag something across a room, all types of that. The next in order is rolling. So this requires even a little less force. And of course you've got anything from ball bearings to rolling things on top of logs to all kinds of types of wheels. And all those are types of rolling friction. And then the least amount of friction is the fluid friction. This would include water, air, and ice, as well as different types of fluid lubricants that are out there. So all of these are fluid friction. So friction in order from greatest to least would be starting with static friction, and then kinetic friction, and then the three types of kinetic friction. It goes from sliding, rolling, and then fluid friction. All right, let's talk about how ways friction can benefit you. It helps you be able to walk. You would have trouble walking. Try it on ice sometime where friction is really low. But if there were zero friction, you wouldn't be walking very well at all. Then it helps with traction, whether that's traction for your ATV, as this picture shows, or motorcycle, or just on the football field. And then also it can assist you in heating things, whether that's making a campfire or an electric stove. All those use friction to heat the things that we want heated, or heating our house, all those kinds of things. Ways to increase friction. You can add more weight or pressure. This is by adding more weight, you essentially increase the normal force on an object, which is the pressure between the two surfaces. You can change the surface material. Go to either a more sticky material or a less sticky material. Rubber is actually very sticky, like nylon is not. You can change the type of friction. You can go from the sliding to the rolling to the fluid. And if you want to increase it, obviously you'd go from fluid to rolling to sliding, right? But in most cases, increasing the surface area does not affect the amount of friction. You're going to find that's true in most cases, not in all. Harmful effects include abrasions, such as your knees getting skinned on a carpet or on a basketball court or on an AstroTurf. Heat can sometimes be a negative thing if you don't want it to, like overheating your engine. And of course, the biggest problem with cars is eventually you will have machine wear and tear due to the friction between the two surfaces. Ways to reduce the harmful effects of friction is, again, you can do the opposite of what increases it, reduce the weight or the pressure, the normal force. You can smooth the surfaces, polish them, sand it. You can, again, change the type of friction. In this case, you'd want to go from a greater type to a lower type, so from dragging something to rolling it, or fluid friction, even the lowest. And then change the surface material, so you can use glass, metal, or Teflon. Teflon's used in your pots and pans. And then finally, you can add a lubricant that reduces the friction. That's what we do mostly in cars with oil. But again, just making the case that in most cases, surface area does not change the amount of friction, either positive or negative. All right, these are just types of lubricants you can add to it, types of surfaces you can add to it. So this pretty much takes care of friction, with the exception of one more thing we got to cover, which is the coefficient of friction. So this is a scalar value that is used to describe the ratio of the force of friction between a body. Basically, this is derived by taking the amount of normal force that an object has and dividing it by the friction force. Or actually, I said that backwards. So you're going to take the friction force and you're going to divide it by the normal force. So friction force divided by normal force is going to give you this mu, or the coefficient of friction. We call it the mu because this Greek letter right here is the Greek letter mu. So that's what it's called, and that's why the lab that you do in class is called the mu of the shoe. So this is the symbol that's used for the coefficient of friction. Note that the coefficient of friction is a unitless dimension, so it has no units, and it is a scalar quantity. So it's, again, this is the formula for calculating it, and we're going to talk quickly about the formulas for calculating the friction force if you're given the mu. So this is one formula that you're going to write on your notes, and the other formula would be if you're given the mu and you want to calculate the friction force. So if you want to calculate force of friction given the mu, you would just simply take the mu and multiply it by the normal force. So you're going to take the mu and you're going to multiply it by your force normal, and that will give you your force friction. And of course, that makes sense when you think in terms of solving for the mu. You're going to divide by the normal force, just algebraically. All right, that takes care of your friction notes, and I'll see you on the next video.